Welcome to this edition of DIY3DTech.com. In this episode, I'm going to demonstrate how you can become electrocuted by a Chinese laser cutter. So one of the things that prompted me to do this video is I've been watching a number of YouTube videos of people using these Chinese laser machines, and it's just really scaring the heck out of me. So some guys have them on mobile platforms where they wheel them around their shops without proper grounding and all kinds of crazy stuff. So I kind of want to go over some of the dangers, and I want to demonstrate this actually firsthand. So one of the pieces I'm going to do is actually simulate what happens when you lose ground on one of these laser cutters and how dangerous it can be. So long story short, I've removed the ground. So I've simulated a loss of ground from the cathode. So if the wire becomes separated from the cathode, or there isn't a proper ground on the machine, here's what's going to happen. So now what I want to do is I actually want to start recording this. So that's recording. So one of the things, I want you to watch the meter down here, and I want you to watch over there at that grounding lug. Now I've got another camera set up here that's going to record a little bit better image of this, or at least closer, so you can see. And also this is recording, is a high-speed recording too. So what I'm going to do is I'm just going to hit the test button, and I'm going to be very careful. I've got safety glasses on, as well as insulative protection, so do not do this at home. But here's what happens if your laser cutter loses ground. See that arc? That's 15,000 volts, folks. As I'm pointing that spark there is 15,000 volts, so it's enough to arrest your heart. So very, very dangerous. Now, a couple of the things that I do want to talk about in this, now that I've got your attention a little bit, is one of the things, watch the meter down there as I do this once again. So notice I'm putting about 23 milliamperes down here. Let me do it again. So watch the meter down here. See that? Alright, so it's about 23 milliamperes. That's not a lot of current, but it is a lot of voltage. So when we look at voltage and current, there are two main things that we look at with regards to electricity. One is voltage, which is the electromotive force, and two is current, which is the amount of volume, if you will, of the electrical discharge. So the electrical discharge at basically 23 milliamperes is rather light. When you get electrocuted, what kills you is the current. However, so a lot of people are sort of a little bit misled by the fact, okay, this is only 23, it's going to knock me on my butt. Well, what's going to happen is if you complete a current through your body, through both of your hands, let's say, if I were to grab that with one hand and grab the ground with the other, that's going to pass right through my heart, and it stands a good chance of arresting my heart and killing me. So this is what people don't understand. These machines must have an earthen ground. No questions about it, or you're taking your life in your own hands. Because exactly what's happening is I've separated the ground, so it's seeking a ground. And electricity will seek the path of least resistance. And in this case, I'm going to shut this off for a second. In this case, it's this path right here which I've created. So this machine right here is actually tied into an earthen ground rod outside of my house through a pretty significant grounding. So in my shop here and for the house, I have a very sophisticated, I wouldn't say sophisticated, but adequate grounding. And this is very, very important, because if you do not have proper grounding, electricity will seek the path of least resistance, and if that is through your body, it will kill you. So be very careful. Now, a lot of people think, oh, this is like, getting shocked by a spark plug. That's high voltage too. Well, there's a little bit of difference here. Number one, if you grab a spark plug wire on your car, and say you have a 6-cylinder, you're only getting hit 1 out of every 6 times. So it's not a continuous pull. This, my friends, when that button is pressed, when this is happening, that is a continuous pull that will arrest your heart. The spark plug thing also stands a chance of arresting your heart if it's passing through your body too, but this more so because it is more energetic and it is a constant pull. It is not pulsed for purposes of this discussion, so it's very dangerous. So be very careful and ensure your machine is properly grounded. You can't put it on a cart and roll it around your shop and go by your ground. Now, I'm going to turn the unit off, and actually I'm going to probably stop this, and so there's going to be a little bit of motion magic. Okay, so what I've done now is I've unplugged the laser cutter, and let me move this out of the way. So now I've got my plug here, which has got the ground lug on it. Now if you don't have it to an earthen ground, what's going to happen is all that's going to discharge through this ground. Now one of the things I want to show you is what I've done is I've connected to this ground lug to this power cord, and you can see right here I'm running about, as I move it, roughly around 6 to roughly 8 ohms on my ground. So this ground loop is creating right now about 7.6 ohms. So the thing is, if this ground is not to an earthen ground, what happens if you touch this machine, even if it's plugged in, and you happen to be a lesser resistant ground than this, that electricity will travel through your body. So a typical good ground should be about 6 ohms or a little bit less. So you can see right here that this is a little bit of a questionable ground in itself, being up around 8 ohms. So this is a little bit problematic and risky. This is why it's so important that this be grounded back here to a solid earthen ground. So at least this way you have 2 channels for that ground to pass, or that charge that I showed, the arcing. You have 2 paths for it to pass. One is through the plug ground, which is a rather poor ground, and then one is an earthen ground, which is a better ground. And so because one of the pieces, I'm going to take this off now. I'm going to take this back over here, and now this what I'm going to hook up here is actually the ground side to the power supply. Now notice, I'll spit it out here. Notice this has a little bit higher grounding than resistance than going to this. So this is my point. The 2 are connected, and actually if you look on the machine in the back side, it's probably tied off to this very lug. It is on this machine if you were to look back inside through here. So this is why this is very dangerous, and it's so important to have that earthen ground. Also, if your machine does not seem to be working right and you don't have an earthen ground, that's probably the problem, because this is, in short, the anode creates the pull and the cathode creates the push, if you will, for the electrons. So it needs a good solid ground for it to function properly, number one. And number two, for safety purposes, it needs to have those multiple grounds, because this is a metal case, and if that discharges to the metal case, again, you run the risk of dying. So this is, I think, a very important video, because I'm really seeing a lot in the various YouTube videos of misuse of these devices, and it can be extremely dangerous, and that's one of the things that I wanted to show, is simply how dangerous this can become. Now, one of the other things I want to point out, and I can't pull it too far along, but I think you can see it here if I get it in frame. This is the plug to the water pump. Do you notice something? So if we look at this plug, and we look at the plug to the actual laser cutter itself, and notice the difference? This doesn't have a ground. So what happens is 110 volts with the ability to deliver 15 to 20 amps is being run into a 5-gallon bucket of water with no ground opportunity, because technically that's a double insulated pump, or should be a double insulated pump that's made in China. So do not stick your hands in the water. If you stick your hands in the water while this is plugged in, you run the risk of electrocuting yourself, because if that pump is not properly insulated and there is the least little bit of leakage in there, then you're going to have 110 volts in a bucket of water. You will electrocute yourself. So these are great little devices if respected. But the one thing, again, I'm seeing a lot on the YouTube channels is that, you know, folks aren't really, you know, number one, I think it's they don't understand, first off. So it makes it very hard to respect. And I don't think they understand the amount of voltages and everything that take place in this and the pieces that are involved in this. You know, they might be respectful of the laser itself, but not, again, of the electricity and the electrical components, and the fact that this is, quite frankly, a little bit on the shoddy side, if you know what I mean. So again, you want to use care. The other thing, you know, I kind of want to just focus on the electrical part in this, and I think I've done that, but the other piece that I want to do is, number one, make sure you get an appropriate pair of infrared safety glasses for your machine. So this is about 1064, I think, wavelength, 1064 nanometer infrared. So make sure you get the appropriate safety glasses for it. Do not, I don't have another pair laying around, but you know, a lot of the visible light lasers are simply color shielded. This needs to be not color shielded, because you notice these are clear. And what happens is these are, number one, safety glasses, but number two, have acrylic inserts in them of a specific size, and you can kind of see a little bit of the polarizing to impede the infrared light from passing through. And again, you don't want the beam to pass through these, but this is why infrared cuts acrylic and everything like that so well. It's because the acrylic attenuates the infrared laser so much. The other thing I want to point out is fume removal. So, I cringe every time I see somebody cutting polyvinyl chloride or PVC on the internet. Very, very dangerous stuff gas-wise. Even certain woods will give off poisonous gases depending on the woods itself. So you need to make sure that you have this vented at a fair distance from where you're using the laser or where people are going to breathe. So very critical. Might do something on that in the future, but again, I've seen a couple videos of folks that got these, didn't understand it. Even one gentleman mentioned about hearing arcing and getting shocked by his unit, and again, that just really sent worries and prompted me doing this video. So anyways, again, these are great tools. Be safe, secure. Again, I'm not an electrical professional. I know enough about electricity. Oh, and the other thing that I want to, again, kind of, talk about a little bit too in the electrical safety realm is a lot of people are under the misnomer that voltage doesn't kill, because again, at the onset of this, I mentioned what really kills is amperage or current. Now, what happens is that's what fries you. So the high voltage piece in low current can arrest your heart and all kinds of other bad things. But the one thing is to also be careful with low voltage, because I know of an example during my day job. I've built a number of very, very large institutional data centers into the million of watts capacity, and most of those data centers have battery backups, 12 or 24 volt batteries. And unfortunately, I've seen one time where somebody actually grabbed a hold of what's called the bus bar for the battery backup and actually was electrocuted off of 12 volts. But that 12 volts carried with it thousands of amperes with it, and so was not a pretty situation. So again, always when working with electricity, be very, very careful. Make sure that everything is properly grounded, like I have over here. Now, it doesn't take a big wire, as you notice, because we're only talking about 23 milliamperes, so you don't have to have a big wire, but make sure it's a good solid ground. And this goes for all your major electrical devices, especially if they are not double insulated. You want to make sure that you have a good ground to them, and that's why in my shop area I have got a good external ground run that I can tie various devices and that into. So hopefully this helped you. Maybe it wasn't so interesting, but if it prevents an accident, hey, that's what makes me happy about this whole situation, and that's the main reason I'm doing this particular video. Is again, if it prevents one accident, it was worth doing this video. So hopefully give it a thumbs up. Cheers. See you in the next video.
Please click like below and subscribe to the channel to keep up to date on all of our projects.